I'm Hemlata. I'm here to share some quotes. The true meaning of the life is to plant tree under whose shade you do not expect to sit. The meaning of the quote is plant tree that might not be helpful to you, but it will be helpful to others. Said by Nelson Henderson.
T equal to 0, the switch is moved from, switch K is moved from position 1 to 2. Initially, it is at position 1. Initially, it is at position 1. Initially, it is at position 1. At T equal to 0, it is transferred from 1 to 2. Therefore, some energy will be stored in the inductor. While transferring from 1 to 2, energy will be transferred, energy is stored in inductor L at T equal to 0. Because it is given that a steady state having previously been established at position 1. So, very long time it is at position 1. That's why transient over, now it is at steady state. It means at 1 it is at steady state. Steady state means inductor becomes conductor. Steady state means inductor becomes conductor. Therefore, at t equal to 0 minus, what is current I of 0 minus equal to what? No inductor, because at steady state already. Steady state is established already. That's why only resistance. Therefore, the voltage is V, the resistance is R1. That is the current. Now, what is the current through inductor at t equal to 0 plus same current, V by R1? I understand this point. Initially, the circuit is like this. Voltage is V. At steady state, what is the current through L? I equal to V divided by R1. V divided by R1. At steady state current through the inductor. If we transfer from position 1 to 2, the inductor will not change its status immediately. That is the nature of inductor. Inductor will not change its state immediately. It retains that state. What is the state? Current through inductor is V by R1. It will maintain that current even at 0 plus. Even at 0 plus. How capacitor has some voltage, like that inductor will have current. Inductor will have current. That current is V by R1. That is in that coil. That will be retained at 0 plus. Therefore, I of 0 minus equal to V by R1. That is given. What is the circuit? The circuit is at t equal to 0. From t equal to or t greater than or equal to 0, the circuit is R2, R1 inductor. The inductor has an initial current of I of 0 minus equal to V by R1. Inductor has initial current of V by R1. This is t greater than or equal to 0. This is t less than or equal less than 0. Less than 0. During less than 0, this is the circuit. After greater than or equal to 0, this is the circuit. Now we have to find current for this. We know that there is a current through the inductor. This is at, this source is at 0 plus. This is at 0 plus only. Now we have to find the I of t through this circuit. Let us assume that current through this is I of t. So now let us write the expression. What is current through R2 minus R2 I of t? Why minus? We are traveling along current direction. Minus R1 I of t minus L di of t by dt equal to 0. We are not, while writing time domain, we won't consider the initial condition. After taking Laplace transform only, we will consider the initial conditions. If we take Laplace transform, before that, let us change this sign, because all minus, that's why we'll make it as plus. Therefore, if we take Laplace transform, R1 plus R2, I of S plus L, S I of S minus I of 0 minus equal to 0. Now substitute I of 0 minus equal to V by R1. Initial current in the inductor is V by R1. Substitute here. Therefore, what you will get is R1 plus R2 I of S plus L S I of S minus L V divided by R1 equal to 0, or I of S equal to L V divided by R1 whole divided by L S plus R1 plus R2. This is equal to, if we take L outside, you will get V by R1. You are taking L outside. S plus R1 plus R2 divided by L. That is equal to V by R1, 1 by S plus R1 plus R2 divided by L. We know that this is I of S. We got the answer. We have to find the current we got, but in frequency domain. So we have to find in time domain. So we have to take Laplace inverse. We know that Laplace inverse of 1 by S plus A equal to e power minus AT. That we know. By using this expression, we can write I of t. I of t equal to V by R constant e power minus, here A equal to R1 plus R2 divided by L. Therefore, R1 plus R2 divided by L multiplied by T. I of t equal to this. I of t equal to V by R e power minus R1 plus R2 divided by L. It means the current will be like this. If you draw the plot, it will be like this. What is the initial current? V by R1. That is initial current. It exponentially decreases and comes to 0. This is I of t. Because if you substitute t equal to 0, in this expression, if you substitute t equal to 0, you will get I of t equal to I of 0 equal to V by R1, sorry, V by R1. V by R1 we got. That is the initial current. What is final current? If you substitute t equal to infinity, you will get final current. E power minus infinity equal to 0. Therefore, final current I of infinity equal to 0. That's what we got here. Initially, it is V by R1. Finally, it is 0. Finally, it is 0. Initially, it is V by R1. Finally, it is 0. Exponentially, it decreases. Exponentially, it decreases.